Hello students, good morning everyone. Welcome to Numericals Studio, the channel where physics become easy and concept become clear and learning become interesting. So if you are preparing for class 11, 12, JEE or NEET, then this channel is going to be a great help to you to understand physics step by step with numericals. So friends and students, please do not forget to like, subscribe and comment and show your support in this journey. Today we are going to discuss a very important topic of class 11 and as well 12 also. That is about vectors and scalars. Friends, if you're just talking about the physical quantity, then every physical quantity needs to have some kind of parameters for its complete definition. And one of the important parameter is about location of that particular thing, that where the particular thing is located. So in order to locate something, we have different kind of system that you have read in past in maths also, and that system is called the coordinate system. You understood that there are 4 quadrants, and this is nothing but the Cartesian coordinate system where I have shown that some point P, Q and X. So you can see, you can tell the position of a particular point with respect to x-axis and y-axis, because we are just dealing with 2 dimension right now. At the same time, we can locate the position of a particular point with respect to the distance from the origin and at what angle this position, this point is here. This particular thing is called polar coordinate system, where we define the position of a point with respect to r and theta, an angle measured in counterclockwise direction. So from this particular triangle, you can understand that this, if we just try to convert this Cartesian system into the polar coordinate system, then it will be very easy using the trigonometry. In the next figure, you can see that we can replace the x as r cos theta and y as r sin theta from this particular triangle, because P, the perpendicular by hypotenuse, that means the y by r is sin theta. If y is equal to then r sin theta, and similarly base by hypotenuse is cos theta, so base can be written as r cos theta. I hope so far we are clear that why Cartesian and polar coordinate system are used to locate an object and in what reference they are used. Okay, in what context they are used. Friends, so as I told you that in order to define a particular, physical quantity, sometimes we need to have, sometimes we need to define the location of an object also. So based on this, we divide the most of the physical quantity in 2 types. First is called scalar and second is called vector. For example, if I'll ask you, go and take 1 kilo of fruit, then you know that you don't need the location, you don't need the direction associated with for its complete definition. 1 kilo is itself sufficient to give the definition of that particular thing, that is called mass. Okay. Similarly, if I'm saying just go 5 kilometer, okay, though it is not making in which direction you should go 5 kilometer, but at least 5 kilometers is telling you, giving you an idea that I am talking about a distance. Okay. Similarly, if I'm telling you just run at a speed of 5 kilometer per second or 5 kilometer per hour, then again, if the direction would have been there, it would have been much better explanation for the event, but 5 kilometer per hour itself sufficient to give you an idea that we are talking about speed. But when you are just merging the magnitude and direction, then this particular quantity is called the vectors. For example, if we just talking about that, is just go 3 kilometer in northeast direction, that means you are talking about a displacement, not about distance only. Okay. So that's why vectors quantity and scalar quantities are different in terms of magnitude and direction. If a quantity having magnitude and direction both, it is called vector. Otherwise, it is only a scalar. Okay. Now, whenever you try to note a vector, how you are going to note it? See, I am just moving from A to B. And if the magnitude of this particular length is A, then we can show the vector as A vector and its magnitude can be shown as the modulus of A. And modulus of A is always positive. Okay, always positive. It can never be negative. See, length can never be minus 1 meter. It will always be 1 meter. Okay, distance will be always 5 meter per second, not negative 5 meter per second. Okay, clear? Now, since a vector is there, so vector has to, like 5 kilo fruits, 5 kilo oranges and 5 kilo mangoes are same in terms of their weight. But 5 meter per second in north and 5 meter per second in south cannot be equal, because both are representing different directions. So for a vector equality, it is important that the vectors should have the same magnitude and direction. You can see the x and y, they can be said the equal vectors because they are pointing in the same direction, having the same length. At the same time, you can understand over here that if you just try to move a vector parallel to itself, then the same vector can be termed as the equal vectors also. For example, you can see if I'm just moving this x vector to this direction, so x can be parallel to y, because x and y are almost parallel. So parallel vectors are also called equal vectors if they are having the same magnitude and direction. Okay. Now, then why, when you're just talking about a vector addition, because if there is a quantity, like suppose if I'm just giving you 2 rupees fine and I'm just giving you 4 rupees more, then it will be the 6 rupees. You can just add them. But can we have the simple addition system in vectors also? I think you have your answer. It is not possible, because to add a vector, you need to consider its directions also. So, in order to add a vector, there are two graphical methods or two methods of vector addition. First is called the triangle law of vector addition, and another called is parallelogram law of vector addition. In triangle law of vector addition, you can see that A, B, and B, C. This is called head, and this is called tail. This is called tail, and this is called head, or tip or tail. This is called tip and tail rule. So, AB plus BC will be AC. Understood? AB plus BC will be AC here. So in order to yes, this A vector and this is B vector, so this will be A plus B vector. Okay, so both the vectors are basically one of the vector is on the head of the another vector. Okay, similarly in the parallelogram law of addition, both the vectors are originating from the same point O. Okay, and going in two different direction. Then the diagonal is the resultant. Okay, this is the A plus B. Clear? Now, yeah, at the same time, you can understand that A plus B vector will be just equal to B plus A vector. That is called commutative law of vector addition. And another is A plus B vector plus C vector equal to A plus B plus C vector. This you can try at your end because this is not that difficult. So, vector basically follows two rules, commutative and associative rules. Okay. So, I hope so far we are clear on the vector additions part. Now, let's try to solve a numerical based on the vector addition that we have just learned. So, we just need to express the vector W in terms of U and B. Now, we have got two, this ABC is an isosceles triangle and APC is a right angle. So, that means this particular thing are equal. Okay. So, from this particular triangle 1, okay, you can see that CA plus CAP would be CP. Okay, from the triangle 1, like CA plus AP will be CP. So, U plus AP equal to V. So, AP can be written as V minus U. Similarly, in this triangle, you can see CP plus PB equal to CB. Okay, CP plus PB equal to CB. So, V plus PB equal to W. So, PB can be written as W minus V. Now, AP in this direction and PB is also in this direction. So, both the direction having the same direction. So, if the vectors are having same direction, and at the same time they are having the equal magnitude, because they are, as I told you, it's an isosceles triangle, and this particular angle is 90 degrees. So this base will be equally divided. So magnitude of AP will be magnitude of PB, and the direction of AP and PB are same. So both the vectors can be same. So V minus U equal to W minus V, and from here we can calculate easily W equal to 2V minus U. I hope this is very simple using a vector additions rule. I'll more problem on in terms of practice series, numerical practice series, daily practice series on vector additions in my next video, so that we'll have more hands-on with the topic and try to understand, try to grasp the concept. But since today we are just touching the concept part only, so I'll be touching numerical in that context, so that our concept become much more clear. At the same time, you can see the vector additions, addition that A plus B equal to B minus A, B plus A. At the same time, you can write A minus B can be as A plus minus B. Okay, what is the negative vector? Negative vector is nothing but the vector which is anti-parallel to each other. So, if A and B are anti-parallel and equal. So these vectors can be written as A equal to minus of B. Okay, so this vector is A and this vector will be B. Okay, okay. They are same in magnitude but opposite in direction. Okay. Now let's talk about the vector components. What is the vector component? Suppose I am just moving with the velocity v at a direction theta with the x-axis. Then this v can be, further divided into two components. One in towards the x direction and another towards y direction. So vx can be from the trigonometry. Vx can be written as v cos theta and vy can be written as v sin theta. And v ultimately from this right angle triangle can be written as vx square plus vy square. Okay, and this tan theta can be written as vy component by vx component. Okay, so since x is pointing in v cos theta is pointing in x direction and v sin theta is pointing in y direction, so we can write as vxi plus vyj, where I and j are nothing but the unit vector representing x, y, and z direction. So friends, you have heard this concept for the first time. What is a unit vector? So I'll try to cover this. Just have a patience. Okay. So let's try to solve based on this resolution of vectors. See, there are three forces and we need to find out the force F3 so that the entire object be in equilibrium, static equilibrium. So whenever you are talking about a static equilibrium, actually the meaning of static equilibrium is that all kind of forces and torque. Let's omit the torque right now. So all kind of forces acting on a particular object or particle is zero. So that means summation of all the Fx and summation of all Fy must be equal to 0. So if we just try to find out the x component, so F1 is already in the x component, so Fx can be written as F1 simply, and this will be the cos theta component in the x direction, so we can write F3 cos theta. Sometimes you might find it difficult that why F3 cos theta in this direction, this theta is greater than 90 degrees. So do we have to consider? So you can do also, you can take this as a 90 degree minus theta and you can divide this thing, and again this you can take this is the negative x direction. Okay, x direction, and this will be again what? This will be pi minus theta. Okay, so you can divide this F3 in this direction also. This will be negative f cos pi minus theta and positive f3 sin pi minus theta. So it depends completely on you. Similarly, for Fy, we can see f3 sin theta plus f2 sin 1. This is f2 sin 120 degree. Okay. So since the Fx and Fy equal to 0, we can equate these things and find out the F3 cos theta. I want you to send me the solution of this particular problem because I have just shown you the concept, and I expect the more and more you should depend on yourself, because I just want to be the problem solver for you, not just want to solve each and every problem for you, because in that case you will not have that kind of grip when a new question basically comes before you and you have to apply the concept. Okay friends, so let's move ahead. So as we just discussed that I, j and k are nothing but the unit vectors pointing in the direction of x and y and z. So what is a unit vector? Actually, unit vector is nothing but unit vector is a kind of vector whose magnitude is equal to 1. So how can a vector have magnitude 1? In that case, the vector may be represented as like this. Vector v divided by magnitude of vector v, and if you just try to find out the magnitude of this particular vector, it will always be 1. Okay, so if you take the unit vector's magnitude, it will always be 1. So unit vector is nothing but the vector which is parallel to a given vector. See, parallel to a given. See, v is there. So, sorry. So unit vector u will be always parallel to v, and u, magnitude of u will be 1. Clear? So what is a unit vector? Unit vector basically represents the direction of a vector, parallel to a given vector. Okay. And its magnitude is 1. Okay, so let's try to solve a particular problem. Find a vector in the same direction as 3i plus 4j whose magnitude is 3. So we need to find out a vector which are having a same direction to 3i plus 4j. So which of the vector is always having a same direction to a given vector? That is nothing but a unit vector. So suppose if a is the vector, then the unit vector of a in the direction of v, then vector given is 3i plus 4j. So vector v by modulus of vector v. So 3i plus 4j equal to 3 square plus 4 square, the 3 by 5, 4 by 5. Okay. Now we need to find out that the vector should have magnitude 3. But we know the magnitude of a will be 1. So we need to find out a vector which is 3 times longer than this. So it will be 3 of magnitude of a. So this will be 3 times of a. So if 3 times A, that means 3 multiplied by this particular vector. Okay. So that's why it is 9i plus 12j by 5. Okay. Friends, if you just try to find out the magnitude of this vector, you will find that 3 can be taken as common and it will be 1. Okay. So this completes our first topic on vectors and scalars, covering the vector addition, subtraction, and component of vectors. In second part, we'll be bringing the vector products. Okay, there are two types of product, scalar product and vector products. But before that, I'll be introducing you one practice series on vector additions, okay, and resolving. And I hope that you'll be able to solve those problems with flying colors. So friends, I hope you have liked this topic, and we'll be keep bringing on this kind of things on physics, and this will definitely going to strengthen your concept and your ideas to face any unseen challenges that is expected in any examinations, and you'll have a very good marks that is possible that you can expect. Even the medicals examination also depends on the amount of marks that you can get in physics, because this is the area when a medical students find them some weak. But I am promising you, you will not find it weak, and you will just pass out your NEET examination with flying colors and have very good marks in physics also. So friends, please subscribe the channel, and so that we can also enjoy our journey to facilitate all these educations, quality educations at your hand, fingertips of your hand. And thank you friends. Thank you for your time, and have a great day.
Free audio post-production by alphonic.com.